square trinomial, you have to take that middle number, divide it by 2, and square it. So that creates that perfect square trinomial. So C is the value that you can add to your problem to create that perfect square trinomial. So 16 divided by 2 squared, 14 divided by 2 squared. All of the C's are positive because when you square something, it becomes positive. So when you get your perfect square trinomial, you're always adding that C value to it. So our goal is to look at completing the square today with more complex numbers. We're also going to talk about vertex form. So how can we rewrite the equations in vertex form, etc. So in example number 1, we have 2x squared minus 7x plus 5. So completing the square problems are unique to all the other problems we've done so far in the sense that we do not want it equal to 0. We want it equal to our C value. And we must get rid of A, which sometimes creates fractions. So completed square problems are like the anomaly of quadratics. So we're going to divide everything by 2. So I get x squared minus 7 over 2x plus 5 over 2. And then we're going to get it set equal to 5 over 2. And then we are going to complete our square. So to complete the square, you're going to take that 7 over 2 and divide it by 2. When you take 7 over 2 divided by 2, it's kind of like multiplying the denominator by 2. So we end up getting 7 over 4. And then what you have to do is square that number and add it to both sides. So you're going to take the 7 over 2 divided by 2 squared, which is 7/4 squared, which is 49/16. We're going to add that to both sides. And again, doing this without a calculator, you would want to change that 5 over 2 by multiplying it by 8. Sorry. So you multiply by 8 on top and bottom to get your common denominator. So that would give you negative 40 over 16. And then you want to add that to the 49/16, which leaves you with 9/16. So my new problem becomes x minus, because this sign was negative, that middle value divided by 2, but not squared, so my 7/4 inside my square equal to 9/16. So I have thus created my perfect square equal to the number. We have to take the square root of both sides. When you take the square root, it creates the plus or minus on the numerical side. So you get x minus 7/4 equals square root of 9 is 3. Square root of 16 is 4. So you end up with x minus 7/4 equals 3/4. And x minus 7/4 equals negative 3/4. Because again, it's equal to that plus or minus of that square root. And then we're just going to add 7/4. So you get x equals 10/4. You're going to add 7/4. So 7 minus 3 is 4/4. 4 divided by 4 gives 1. You can reduce 10/4 to 5/2. You can also also leave it as 10/4. Getting rational numbers, such as 5/2 or 1, meant that this was actually factorable. So getting those rational numbers meant that this was actually factorable. So you have x squared plus 8x equals 22. So again, you have to move the 22, and then we're going to complete the square. So I'm going to have 8 divided by 2. And squared. So again, I take that b value, divide it by 2, so I get 4. 4 squared is 16. So I'm going to add 16 to both sides. So that makes this x plus 4 quantity squared equals negative 22 plus 16 leaves me with that negative 6. So now I have something squared equal to a negative. This is where knowing how complex numbers works really comes back into play. When I take that square root of both sides, I am going to end up with an I. So x plus 4 equals plus or minus I, square roots of 6, because that negative comes out as the I, and then I move over my 4, and I get x equals negative 4 plus or minus I, square roots of 6. X squared plus 10x minus 8 equals 0. So we have 2 tasks we have to do to start our problem. Not only do I have to divide by 3, but I also have to move my 8. The order with which I do it doesn't matter. So in example 1, I divided everything first. Here, I could technically move the 8 first and then divide by 3. But again, the order doesn't matter. So I end up with x squared plus 10 thirds x equals 8 thirds. I'm going to divide 10 thirds by 2 to get 10/6. I'm going to square that value and add it to both sides. So that adds 100 over 36 to both sides. That makes my middle term x plus 10 over 6 squared. And again, if you want to reduce 10 over 6, it really, both divided by 2, is 5 thirds. Same with even my 136. Both of those divide by 2 and 4. So if I divide 100 by 4, I get 25. 36 by 4, I get 9. Well, now if I want to add 8 thirds to 9, that's a lot smaller of a denominator than adding it to 36. So we're going to multiply by 3 over 3. So 24 and 25 give me 49 over 9. So I get x plus 5 thirds equals plus or minus 7 thirds. Therefore, x equals 7 thirds minus 5 thirds, which is 2 thirds. and x equals negative 7/3 minus 5/3, which is negative 12/3, but negative 12 divided by 3 is negative 4. Again, you can show more lines, you can do the math in your head, it's totally your call. Are we okay with that? Okay. So the next one, we have x squared plus 2x plus 2 equal to 0. This one is nice because the a value is 1. We're going to subtract the 2. Find my c. So 2 divided by 2 is 1. 1 squared is 1. You have x squared plus 2x plus 1. So that becomes x plus 1 squared equal to negative 1. So again, that complex number is going to come into play. That negative is going to become an I. And you're going to subtract it over. So square root both sides. Put your plus or minus when you take your square root. Change the negative to an I. Subtract. Get your complex number solution from completing the square. So then in example 5, it says a parabola is modeled by the following equation. Jane's homework problem requires that she find the vertex of the parabola. So going back to section 5.1, going back to vertex form and standard form. What's nice though now is that we can use the completing the square method to get the problem in vertex form. So we can use completing the square to get it in vertex form. So what we want to do is still complete the square, but ignore the 28 in a sense. So it says she's going to use completing the square to express the function in vertex form. So we have y equals x squared minus 10x. I want to create that perfect square. So I'm going to just move that 28 way over here. Now, in all the other problems, we added the value to both sides to balance the equation, right? So if I add 5 pounds on my right hand, I want to add 5 pounds on the left hand so that I stay balanced. You don't ever want to like carry more on one side than the other. So this time, if I add the c value, since I don't want to mess with a y equals, how do I make it like it's nothing? So what we're going to do is complete the square. So that's 10 divided by 2 squared. So to complete the square it becomes adding 25. But if I want to make it like I didn't alter the problem, if I add 25 on the right side, then I also need to subtract 25 from the right side. So the adding 25 is going to happen to the beginning part. The subtracting 25 is going to happen to the other part. So we're almost treating it like two different parts are happening right now. Because what do you know about x squared minus 10x plus 25? Well, you can rewrite that as y equals x minus 5 b divided by 2 quantity squared, because you completed the square, you made that perfect square trinomial in the parentheses, and then 28 minus 25 becomes So now I took a standard form and wrote it in vertex form. The old way, not going to like that way. Now that you know this way, the old way was when you had to do h equals negative b divided by 2 times a. And we got h was 5. And then to get k, you took that h value and you plugged 5 in. You said 5 squared minus 10 times 5 plus 28. 25 plus 28 minus 50 gave you 3. So the old way was going to find like h and k and then you plug them into vertex form. Well, now you can use that completing the square to manipulate your equation to get it to vertex form. Okay? And then the last one, the area in square inches of a drawing called foliage is approximated by the equation given below. Complete the square and find the true roots which are equal to the approximate length and width. So again, you can use completing the square with any quadratic to solve. So we would say negative 396 equals x squared minus 40. So then you would complete your square. So 40 divided by 2 is 20. 20 squared is 400. So you have x squared minus 40x plus 400 on the right. Means I have to add 400 on the left. So I get 4 equals x minus 20 squared. Square root both sides. Solve for x. And we get 22 and 18. Now I do want to do one homework problem with you because we had a nice problem in which there was no a value. If there's an a value when you rewrite in standard form, then you have to do something a little bit unique, and I want to make sure we cover that as well. Thank you. Nathan knew it. My problem was. Okay, so I want to do problem number 11. So the rule of thumb is that you cannot have an a value. The problem with these are I cannot divide everything by 4 now because I have a y. So we're going to do the factor by grouping among the first 2 terms only. Again, that extra value at the end does not count. So you're going to take the 4 away from here, leaving x squared plus 2x. And again, I want to complete my square within this area. So So 2 divided by 2 is 1. 1 squared is 1. Now, that's what you add inside the parentheses. To balance it, you have to also subtract it outside, right? But if I'm going to take this number to the outside, what happens out in front? Okay, 4. So I'm not just adding, I'm not subtracting 1 on the outside, I'm subtracting 4. So if you have to take out an A, that A affects what you subtract away. So now you have 4x plus 1 squared minus 8. So the 4 has to get multiplied by what you subtract. If it's a 6, a 2, etc. The example problem was a 1, so we didn't see that happening. Make sense? Homework's running back. I'll see you tomorrow.